Hello, critical thinkers, and welcome back. Today's TEK is TEK G3B. Determine the image or pre-image of a given two-dimensional figure under a composition of rigid transformations, a composition of non-rigid transformations, and a composition of both, including dilations where the center can be any point in the plane. This video covers scale factors and dilations, and our learning objective is to describe and calculate the scale factor of a transformation and to describe a dilation. Now, you will know you have mastered this objective when you can actually describe and calculate a scale factor, and you can describe what dilation took place. Every skill you learn in this video makes you a stronger problem solver. I know you can do this, so let's turn your practice into your superpower. Let's start off with the definition of a dilation. A dilation is nothing more than a transformation that makes something bigger or enlarges it or reduces it, makes it smaller than the original figure. And it does it in a proportional way. So a real brief definition would be that it's a transformation that enlarges or reduces the original figure proportionally. Now, this proportionally piece signifies that we have a scale factor. And a scale factor is a ratio, which is a fraction of a length of an image to the corresponding length of the pre-image. So the variable that we use for scale factor is K, okay? And it's defined as the image divided by the pre-image. Please remember that a dilation makes something bigger or smaller. If you remember nothing other than that, then you've gotten a good piece of information from the video. And also, we need to link this back and say that a dilation is a similarity transformation. It is not a rigid transformation, which is also a congruence transformation. So it's not a congruence transformation as well. So looking at an example, I have two images. I have my green pre-image and I have my pink image. So we started with the green and we moved to the pink. Now you could probably in your head go, yeah, it reduced in size. So what that says is if it's reduced in size, the K factor or the scale factor is going to be smaller than 1. The way we calculate the K factor is we take the length of a corresponding side. So let's look at this. Let's start with our pre-image, which is right here. And if we counted the squares, you would get 16 squares going across. Now the corresponding side to that is here on the image. And if we counted those squares right here, we would end up with 12. So we know that K is defined as the image over the pre-image. So I'm going to take my 12 and I'm going to put it over my 16. I'm going to reduce this fraction, and this fraction is reduced to 3/4. Now you know that 3/4 can be written as a decimal, which is 0.75. Now this 0.75 tells you that the figure has gotten smaller. Remember that the 3 dots in a triangle means therefore. So we would read this, therefore, the figure got smaller. Just to remind us that if K is bigger than 1, we get a bigger figure. If K is equal to 1, there is no change. That figure stays the same size. And if K is less than 1, but it has to be bigger than 0, that figure got smaller. If we move to our next example, we're going to see very similar types of issues. We have our green pre-image, which is a right triangle. We have our pink image, which is also a right triangle. And I know that because of the corner markers that are right here. And so what I'm going to do is I'm going to measure a side. So if I measure this side right here, I know that this side measures 6. If I measure my image, I know that this side measures 12. Scale factor K is defined as image divided by pre-image. And so I'm going to take my image, which is 12, I'm going to divide it by 6, and that gives me a 2. Therefore, the figure got bigger. It didn't get smaller, it grew in size. This is it for today's video. Now, if something doesn't make sense, that's your cue to ask some questions. In fact, it's your responsibility to ask questions. You can come to me and ask questions. You can talk to your classmates, your shoulder partners, or even try AI for a step-by-step explanation. We are a team here, and we're all here to help one another succeed. Now, you learn best by breaking complex ideas or concepts down into smaller, more manageable skills. And that's exactly what we did today. You're turning your practice into your superpower. Now, you know I believe in you, and I know you can do this. You are working your way to success one skill at a time. So I want you to have a great day, and thanks for working with me.